This is number 7 in the first 2.4 homework. We had an example like this in the notes, um, but rather than working the example in the notes, it might be more beneficial to just go ahead and work the example straight from the homework. So this is your number 7 in the first homework for 2.4. It says the total cost, C of x, and the total revenue, which is R of x. Those functions for producing x items are shown below, where x is between 0 and 40. So it first asks us in step A, what is the profit function? Well, it didn't give it to us, but it gave us everything that we need to know to find it. It gave us the cost function and the revenue function. And profit is revenue minus cost. So we can get P of x by saying R of x minus C of x. Okay, which will be, so we're going to write our R of x first, negative a half x squared plus 600x minus 4900 plus 500x. So I need to distribute that negative to the 4900 and to the 500. And then I can combine my like terms to get negative 1/2 x squared plus 100x minus 4900. Let's go ahead and type that in, see if we got it right. Okay. Now it says, when is the profit maximized? And I'm going to follow my steps that are in theorem number 8 for finding total, your absolute maximum and absolute minimum whenever we have a specific interval that we're looking at. And that first step is to, let me get a blank sheet right here. Your first step is to find your derivative. And I usually find both derivatives while I'm right there at it. So p prime of x, and we're looking at the derivative of the profit function, will be negative x plus 100. Okay, I'm taking the derivative of this function right here, the p of x. I'm going to go ahead and find p double prime of x, which is negative 1. Okay, because my second derivative is negative, I do know that my absolute maximum will be at the critical x value, but I am going to keep on going through my steps. So step 2 is to find that critical x value. So you find the critical x by setting the first derivative equal to 0. I'm going to say that find critical x. So that first derivative was negative x squared, negative x plus 100, and we set it equal to 0, so I subtract 100 from both sides to get that negative x equals negative 100. And then we divide by negative 1 to get the x equals positive 100. This is my critical x value. If you look, I'm following theorem number 8 exactly. Step 3 in theorem number 8 is to list your critical x value, which we just found to be 100, and your endpoints of the x interval. So that's 0 and 400. Where did I get those numbers from? 0 and 400. I got them from right over here. It says that x is between 0 and 400. Okay, so list, this is step 3, list your critical x and your endpoints of the x interval, so 0 and 400. Step 4 is to evaluate. So we're going to find what f of 100 is, and f of 0, and f of 400. Okay, I'm going to fill out the first one for you. So, and excuse me, this is actually, I'm used to saying f of, it's actually p of, because our profit function was p of x. But we're just plugging it into the original profit function, which is right here. So I'm saying negative a half times 100 squared plus 100 times 100 minus 4,900. And I actually got a 100 as the value for p of 100. I plug p of 0 in my calculator. I'm not going to write that out, but I ended up getting negative 4,900, and the same value for p of 400, negative 4,900. And see, I evaluated my critical x value and both of my endpoints. And the highest y value, see what I ended up getting, 100 was the point. The x was p of 100. The y value I got was 100. Right over here, my x value for p of 0 was 0. My y value was negative 4,900. Okay, and for p of 400, my x value was 0. My y value was negative 4,900. So the maximum is 100. Okay, so the profit is maximized for a production of blank units. Well, the maximum itself is 100, but it happens at the x value. It just so happens to be 100 though.